Let xn be sequence of real numbers such that limit of xn plus 1 minus xn is equal to c, where c is any positive real number. Then the sequence xn upon n is not bounded, is bounded but not convergent, converges to c, converges to 0. Means we have to tell about xn upon n. And we have to remember some points. If a convergent sequence, then it must be bounded, and the limit of convergence is unique. So as xn is given, and this is sequence of real number, xn is real sequence, and also limit of xn plus 1 minus xn is equal to c. You can choose any value of c, either 2, 3, 4 and 5. Where c is positive real number, then the sequence xn upon n, and we have to tell about limit, because few options are for limiting point as converges to c, option c, and you can see option d is saying converges to 0. So if we can anyhow find the limit, then we can easily discard one of them. And if limit is existing, then we can say sequence is bounded. So we are solving this problem by trial and error method. So consider a sequence which is satisfies the hypothesis. So xn is nc. Otherwise you can choose like 2n, 3n or 4n if you assign the value of c. Then xn plus 1 minus xn will be c, and limit of constant sequence is same, so limit of this one is c. So this sequence xn equal to nc is satisfying the given hypothesis, and limit is also existing of this. So we have to tell about xn upon n. So it will be, as xn is nc upon n, n cancel out by n, so this is c. Means again limit of xn upon n is equal to limit c, means constant sequence, and this is same. So limit is existing, means converges to 0. Obviously it is bounded, and converges to 0, so option D discard here. Option C is correct, is not bounded because of convergent, so it will be bounded, so option A discard. Option B is saying bounded but not convergent. It is convergent and bounded both, so option B is also discard. So correct option is C.